there's a starting point, and each individual term after that has the same difference, they call it. Something's being added to it, something's being subtracted to it to create the second, third, fourth, fifth, 26th term, and so on and so forth. So what happens here is when you're working with these, you wind up with a couple of different formulas to work out. Now, there are going to be multiple different styles of problems that we're going to be able to work with on this. And it's a matter of always falling back upon the same generic formula. Let me go through some of this with you. So again, arithmetic sequences is a difference between the consecutive terms is always constant. Think of it as 2, 4, 6, 8, 10, 12. The difference between each one of them is always a 2. That value doesn't change. It's an addition or it's a subtraction between the two problems, and it's the same amount each and every time. It's not some of those weird nasty ones where it's odds and evens and stuff. This is very straightforward. So what happens here is what we're going to try and tell whether or not they are arithmetic. In order to be able to tell if it's arithmetic or not is, well, first of all, not worried about your 6 dots for right now and go through this. It is driving me nuts too, but I will figure it out. But what we want to do here is tell whether or not each one of these sequences is arithmetic, which means is the difference between each consecutive term the same amount. So going from -3 to 1 adds 4. 1 to 5 is plus 4. 5 to 9 is 4. So on. So is that arithmetic?
Yes.
Yes. Each one of these values going up is the same difference plus 4. So the difference here is just 4. That common difference. Whereas on the other one, it's going 2, 5, 10, 17, 26. It's going up by 3, 5, 7, 9. Is that arithmetic? No. It's a pattern. You could probably figure out the next couple of terms within the sequence, but it is not what we would consider an arithmetic sequence. It does not have a constant difference. All right? It's that explicit, if you will.
So would you say, like, if it asks you whether or not it was arithmetic, and to say the difference, would you say for a problem like that D equals random, like D?
No, what you should say is no.
Oh.
Is this arithmetic?
No.
No. Can you go to the next problem? It's that simple. All right. Whereas if it was a problem like we did yesterday, it would ask you what's the next term in the sequence. It's still something you can figure out, but it's not necessarily something that is arithmetic. All right. Whereas geometric, what we'll talk about tomorrow probably, is that there's the same common ratio. There's a little bit different. It's multipliers. These are additions. So here's where it all boils down to, is this generic formula for working with the nth term for an arithmetic sequence. The nth term is always going to be defined by the first term plus n minus 1 times d. That value of n stands for the number term within the sequence. So if I'm trying to find the third term in a sequence, I would say a sub 3 would equal my first term plus 3 minus 1 times my difference. It's that straightforward as far as how things get substituted into one another. Excuse me. If we go to the example we just had up there, it was it -3, 1, 5, 9, 13. If I go to that first example, and I want to figure out what the 17th term will be within that sequence. What I'm doing here is plucking out the information. You guys told me a second ago that the common difference within that sequence was what? 4. So I know my D value here is 4. I know what my first term is. What is it? -3. I know my first term is -3. Now, again, my suggestion, write this out a few times as you're doing it. It'll help you remember what you're working with. What I did that first step, I know that I'm looking for the nth term. I'm looking for the 17th term. So for n, I put 17 in both spots. Now I know that the 17th term is going to equal the first term plus 17 minus 1 times 4. And from there, I can just use my calculator. Because what's 16 times 4? I should be able to do that here. Subtract 3. There you go. The 17th term in this sequence would be 61 if you continued that pattern. Okay. Does that make sense? Again, it's very straightforward as far as your substitution style is going. Okay. It's very straightforward. Notice that the arithmetic sequence is also a very nice, clean value to be able to find. You should be able to find these without too much of a hassle. Okay, so you're just adding or subtracting. Okay. So let's try another one. I want to write out the rule for the nth term, which means I'm going to write out the generic equation. Excuse me. I'm going to write out the rule for the nth term of the sequence, 50, 44, 38, 32. So a sub n is equal to the first term plus n minus 1 times d. What's the first term? 50. And what's your common difference? Negative 6. Okay. Now the next thing you have to do to this is distribute and combine like terms. So you distribute out the negative 6. So you have 50 minus 6n plus 6. So your rule for the nth term becomes 56 minus 6n. And that's how you write out the equation for the nth term.
So it's like the same thing that you just wrote down.
Right. You're just writing out the rule first, because now the second part of the question is, what is a sub 20? What's the 20th term? What do?
Put 20 in for n.
Put 20 in for n, yeah, yeah,
Is
babe.
it ever going to give us like the 20th term and then ask you what the
Yes.
first term is?
Yep. And it's very simple to do that. Okay. You'll use a little bit of backwards math and some substitution stuff. There's a couple of different ways that we're going to work with this, and we're going to do that here in a little bit. Okay. So just like Noah was saying, if I want to figure out what the 20th term is, the 20th term will be 56 minus 6 times 20. Was that 120? So that would be negative 64. But you know, who's counting? Yeah, they counted. Arithmetic. It's called arithmetic sequence. What's that?
I like her.
It sounds like it should smell
Yeah.
nice. Aerobic. Arithmetic sequence? Arithmetic.
I don't know. It's hot.
It's like putting the emphasis on one syllable.
Yeah.
Syllable, thank you. So here's what Bailey was just getting at. Exactly what you were just saying. I want to figure out what the nth rule is if I know what the 13th term is and I know what the common difference is. Pretty much. Pretty much. So here's what happens. You know that the 13th term is going to be 30 and the common difference is 3/2. Here's what we do. Every time you have these types of problems, always start with the basic. You know that the nth term is going to be your first term plus n minus 1 times your difference. That's the generic form of the equation. From that, I can substitute in two things, actually 3 things. I know that I'm looking for the 13th term, so I know that the 13th term is going to be the first term plus 13 minus 1 times 3/2. And what is the 13th term? 30. So I know that 30 is going to have to equal the first term. Well, 3/2 of 12 is how much? 18, very good. Which allows you now to figure out what your first term is. What's your first term? 12. But are you done? You have to write the rule. So just like you were asking, what do you have to do with from there? Well, once you figure out your first term, you know what your difference is. You just go back to the original equation and you resubstitute it. So some of these problems will take a couple of minutes to go through, just because you have a couple of parts. Okay. So you wind up with 12 plus 3 halves n, oops, minus 3 halves. You always write it back down into combined like terms with just a constant and something. You can, but in this case here, can I just say, what's 12 minus $1.50? Is it the end of the world if you write it as 10.5 plus 3 halves n? Is it really the end of the world? If you want to write it as 21/2, you can do that as well.
What about 10?
That's what I have. To be honest with you, when you get to some of the decimal values that are, halvesy or a quarter, is it really the end all be all? It's really not. But once you start getting into the ones that are the funky fractions, it should be a cool name for a band. The funky fractions. That'd be awesome.
I'm sure that would break things up.
The funky fractals? That could be their main hit on the funky fraction record. Does it get weirder than this?
Yes.
Of course, why not? It's more fun. Well, here, let's do this one first.
Got a name for one of their songs, Mr. Dividing Conquer.
That's awful. That was awful, but it's awesome.
I think it was pretty good.
That was awful, but it was very good. Think about it.
Dividing, going with the math, and then conquer, like you're gonna
Divide and
run the
conquer on the
game.
funky fractions.
You're gonna run the game.
Funky fractals.
On the funky fractals records.
I think we got a band though. I'll be drummer. You can be vocals. We could do like the whole School of Rock thing.
Yeah.
Hold down those shades.
Alright.
That was awful.
Your common difference was 15. So your a sub n is your first term, n minus 1 times 15. So you have 32 plus, oops. So did you get 17 plus 15n? And then you substitute in 12 for n, I'm guessing. Again, probably not very difficult. What'd you guys get? 272? 197. I got 187. 187.
I got 2 seconds.
Uh-oh. 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 All right. Subtract through. 15 times 12. Quick. That's 144 plus 45.
Yeah. Plus 17.
17 plus 180. 197. Thank you. I'll be here all week. I'm sure take your waitresses.
I thought we were supposed to eat the veal.
You can try the veal. It's delicious.
I think the reason I got
Oh, that's try the veal. It's delicious. That's Godfather. It's the scene at the Michael Corleone takes the Irish police sheepdog and chops after Italian. Yes, sir.
I plugged in for Oh, I plugged in 16.
That's why I got it wrong.
Plug in 17.
Here's where things can get weird. This is about as most complex as this stuff is going to get. You are given 2 terms within a sequence.
Oh, man. Oh, wouldn't you just divide
Well,
the
hold on.
distance between them?
Hold on. I know that you guys will be able to figure things out quickly, but I want to show you how you set this up, because not all of them are this simple. In this case right here, we know that the 6th term is 10, and the 21st term is 55. I want to write out the rule for the nth term. So here's what we're going to do. We know that a sub n is always going to be the first term plus n minus 1 times their difference. So I'm going to fill in all the stuff that I can with this one first. So I know that the sixth term is the first term plus 6 minus 1 times my difference. What does the sixth term equal? 10. So now I know that I have 10 equals the first term plus 5 times d. Okay? Can't divide by 5. Because I have an a sub 1 then. I do basically the exact same thing with the 21st term. Again, I know that the 21st term is going to equal the first term plus 21 minus 1 times d, which therefore gives me 55 equals first term plus 20 d. Yes, sir. Very good. Notice, I have two variables and two equations. Yes?
Can you instead look at the difference between the numbers, like the difference between 6 and 21 is 15, and then divide it by the difference between 10 and 55 and 18? Just if d equals 3, we let them know, because that's what I got. I just want to see that.
We'll see what happens. So what happens here to make sure that you get it right is you set up a system. 55 is your first term plus 20. Second one is 10 is the first term plus 5d. What are you going to do?
Get the A's out of there.
What's the difference?
3.
That's fine. Yeah, you use some linear combination stuff. I always go back, I fall back into this one here. Now, that's what's wrong. Okay, I forget. Your guys' brains work a lot different than mine. You guys pick up on patterns a lot faster than I ever did. That's awesome. I wish I could. No, that's great. If it works, go ahead.
Is that always going to work?
That's the thing. What happens if you get negatives and other values? You want to start messing around and
I
messing
still think
things
it
up.
will work though.
That's-
Hopefully. But
Now, in this case now, we're not done though. All I know is that I have a difference value of 3. I still don't know what my first term was. But I do know that my sixth term was what? 10? So you fall back then to the original equation. If I know that the sixth term is 10 and your d is 3, so the sixth term is the first term plus 6 minus 1 times 3. And what's your first term then? Good. There's your first term, there's your difference. A sub n is negative 5 plus n minus 1 times d.
Wait, where'd you get the 6 there?
This was from the beginning.
Oh, okay, I got it.
So it's not that the problems are really difficult, they just take a little bit of time to write out. It's really all there is to it. Okay, it just takes a little bit of time to go back. So you have to reuse your givens to go back into the setup the next step. So now you have that, and of course, whenever you have your nth rule, you always write it in terms of like mx plus b if you want to think of it that way. Negative 5 plus 3n minus 3 gives you negative 8 plus 3n. That's your rule. And why they always put the first term, the a sub 1 first. I guess they've just been doing that for years instead of writing it out in terms of slopes. Again, it's not super complex. It just takes a little bit of time to set up. It's the first Tuesday of May. No worries.
It looks vaguely, it looks bad.
Didn't that happen in April? Wasn't it snowing?
Yeah.
That's be like a really bad day. If
What
it's
is
a
that?
Snownado. Imagine if it was a Sharknado while it was snowing.
Gosh, I feel like
Jump into it.
Just to see what happens.
Don't you?
I saw
Scientific
one.
aspects.
So that was like-
I'm being very specific, falling back to the formula each time, this is always. And then the last bit. The sum of the series.
More numbers.
The sum of the series has a generic formula. Remember we were talking about the sum of the series stuff yesterday, sums of the sequences? We used the summation notation. Well, here it's not so much that we're writing out the summation notation, we're writing out it as a different formula. And what's going to happen here is that the sum of however many that they're asking you to do will be that many times first term and whatever that term is over 2.
So the way would be,
Basically, think of it this way. Inside the parentheses, that's averaging the first number and your last number, isn't it?
Huh?
If that's averaging the first number and the last number in a sequence, isn't it? That a sub 1 and the a sub n, that's the number you're looking for. You're averaging those two values, and you're multiplying it by whatever that number is in the sequence. So if it's the first term and 10th term, it'd be 10 plus 1 over 2 times 10. But you have to do a little bit more. It's not that straightforward, so why would it be? You have to write out some equations out of this. Notice this a sub n is here. That means sometimes we're going to be working with a sub n equaling first term times n minus 1 times d. There will be falling back to that. Again, the arithmetic within the problem itself is not going to be complex. It's remembering where you are within the problem to set things up. Let me show you an example. What I want to do here is I want to find the sum of the first 30 terms of this arithmetic sequence. Okay. And then I want to find how many of them would take to add up to equal 175. There's 2 parts to this. Okay. So with the series we have is 4, 7, 10, 13, 16, 19, blah, 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 blah. What's the difference? 3. What's the first term?
1, 4.
Good. So if I want to find the sum of 30 of them, I know that the sum of 30 of them is going to equal n times the first term plus the nth term over 2. Well, my n value in this case is 30. My first term is 4, bless you. So that means it's going to be 30 times 4 plus 30 over 2. Bless you.
so it would be, it's basically n, shouldn't they just put like n and then a plus n?
Shouldn't it be A 30, A sub 30?
How do you know what that last one is?
Oh, sorry, a sub 30. Thank you. I got ahead of myself.
Okay.
So in order to set that up, you've got to figure out what the 30th term is going to be. So you have to use that nth rule. Okay? Knowing that the a sub n for this problem is going to equal your first term plus the n minus 1 times d. So your 30th term will equal 4 plus 30 minus 1. And our difference here was 3. 27 times 3 is what, 81?
Oh, it's 87.
Okay. But 29, I'm sorry, I thought it was 27 times 3. Yeah, 29 times 3 is 87. 87 and 4 is? So notice, we had to use both formulas to get to that point. So now I know that the 30th term within the series is 91. I substitute that back in. I get 30 will equal 4 plus 91 over 2. In other words, it's 15 times 95. What do you get? Bet you it ends in 5.
You forgot to divide.
14. Wait, what?
Forgot
It's
to
over.
divide. Oh.
1425?
Yeah, 14.
So the sum of the first 30 numbers within this series would equal 1425. We got them all up. I did.
Do you do that when you go on numbers?
Absolutely.
Okay.
Yeah, it's just quicker. I mean, you can, or you can, because you're not adding these things up and get a decimal, unless you have decimal values within your series. Okay. So you just gotta be careful with that. Now, when you have to figure out how many of them it's going to take to add up to equal 175, that's where things get weird. Okay.
Some things are weird.
They did. They got a little weird earlier. So let's go back to what we know. I know that I want to find n. Let me put some on a fresh one. And we had the original equation of a sub n was, first term was 4 plus n minus 1 times 3. So that was, we didn't write this out, but it was 3n minus 3, so it was 1 plus 3n was our nth term. All we did with this problem here is we substitute that in right here. We just didn't write out the rule. Here's a hint. Write out the rule first, because you're going to need it for this part. Okay? Now, in this series, we knew that the first term was 4. Our a sub nth term is 1 plus 3n. That's the rule. When I go back and figure out what's the value, how many of these numbers I have to add up together to get to 175, what I do is I start with the generic formula for the sum. It's going to be that value n times first term plus last term over 2. Well, I know what the sum has to equal. I don't know how many it's going to take me to get there. I know the first term is 4. I know the sub n term is going to be 1 plus 3n. And I know it's all going to be over 2. Are we okay with that?
Yeah.
All right. What do I do first?
You add value.
Okay, I can combine the 4 and the 1, but what am I going to do with that divide by 2? Multiply by 2. Get rid of the fraction. Multiply both sides by 2, we get 350.
Shouldn't you divide by n first?
I'm not dividing by n,
Oh.
because now I have that. Which means I'm going to have to do what? Distribute, and then I'll have to factor.
Ah.
Dun dun dun. Yes, sir.
How did you get the
1 plus 3n?
Yeah.
1 plus 3n is a sub n. It's the generic equation, the nth rule. In the previous part of the problem, we didn't write out the rule for the nth term. You might want to, when you have this style. Because you will always use it for the secondary part. Right, that's all. How do you factor that? Carefully. There's a couple of different ways of going about this. You have graphing calculators. Could you find zeros? Okay? Because I don't want to try and factor that by hand. 3 times negative 350. Well, that's what? 10,000,
Wouldn't you
15 or something like that? It's horrible. I don't want to try to factor that. What times what is 1,050 that adds together to get 5? Big number. If I use my calculator, though, I can graph that, right? I can find zeros, calculate 0. Do you guys agree that you're gonna have one positive value, one negative value for this problem? Which one do you think you're gonna wanna use? The positive value. You wanna use the positive 0 here, because the other one would give you negative numbers. So go to your y equals. What was it, 3x squared plus 5x, and then minus 350? If I go to our graph, oop, there's something over there. Change your window a little bit.
Should you just go to the table
Oh yeah, you can go to the table.
and then just look for when y equals 0?
Dun dun dun.
Calculate what
You can do that as well. Scroll around, find your 0. Your 0 is at 10, so what's your end value going to wind up being? How many of you have to add together to get 175? 10. That's about as complex as this stuff gets. Right? The rest of it, like I said, the arithmetic that you're doing is just distributive properties, adding, combining like terms. It's when you get to this last part, we might have a little bit of factoring that you might have to mess around with. So be careful when you get to that. Use your calculator if you have to. Go through your tables. Now remember, sometimes tables aren't going to give you a fraction, but if you're trying to find out some of these values, you shouldn't get fractional answers anyway, because you're trying to count up how many of them are you going to need to get. So I've got a couple of these for you guys to try out tonight. This is 11.2, page 663, 21 to 26, 30 to 34, 45 to 48. Do those, please.